Um, as you heard, I'm Steve Ritter, founder and chief scientist at Carnegie Learning. Carnegie Learning has been around for just over 20 years now. We primarily, as you can see from our logo, Long Live Math, focus on math, although we also have some curricula in English language, world languages, and computer science. But I'm mostly going to be talking about math, and we are best known for our Mathia intelligent tutoring system, which is formerly known as Cognitive Tutor. So if you've heard about studies on Cognitive Tutor, that's the platform that we're talking about. But what I'm really going to talk about is UpGrade. As we've done research for over 20 years, there's an emerging kind of field called learning engineering, which is trying to use learning science principles to design improvements, particularly in educational software, but also in other educational interventions, potentially. What I'm going to talk about with UpGrade is a platform that we hope helps facilitate one aspect of learning engineering. And so one problem that we have in educational technology is educational software is always changing. It needs to change because new technologies come along with new expectations about what software should do. The academic standards change all the time. We get new use cases, as we're all going through right now, where students are remote learning at home, and we're scrambling to figure out how do we change our content, our platforms, and our approach in a way that improves outcomes for students. And the fundamental question that we're trying to answer is, how do we tell which proposed improvements really are improvements? And the standard solution to this is do a randomized field trial. In the software world, they often call that an A/B test, where you take some software feature, approach, or bit of content and randomly assign it to some of your users. And then you can measure whether the users who got the new feature did better or worse than the users who got the old version of it. But educational software is complex, and it's complex in specific ways that aren't always shared with other types of software. First, when you think about instruction, students need consistency in an approach over time. So if you're trying to teach students fraction operations, for example, it's important to make sure that students get a kind of consistent view and approach to fraction operations over time, including their initial instruction and perhaps later remediation and review. And so that consistency for the student over time is important to keep account of. Also, software, particularly school-based software, is often used in a group, a class. Sometimes it's really important to keep the class approach intact. So for example, if you're experimenting with something where you expect the teacher to support the students, you're going to drive the teacher crazy if you randomly assign students within a class. So you want to keep the class consistent. There are other potential equity issues that drive this kind of cluster assignment that you also need to take into account. And then finally, educational software is often these days adaptive and self-paced. So our software is self-paced and mastery-based. And so what that means is at any given time, different students may be doing different things. And in particular, if you're running an experiment on, the quadratic formula, some students in a class will have done the quadratic formula last week. Some students are doing it right now and will be in the experiment, and some students maybe won't get to it for another 2 weeks, and they'll miss that experimental window. And so when you cross that with the issues about individual student consistency and class consistency, it becomes logistically complex. And one of the things that's key when you start to scale is all the rules and principles for deciding about anomalous conditions need to be decided up front so that the software can follow strict rules about how to manage those situations. And that's what our UpGrade platform is doing. So I'll give some quick examples of types of experiments that we're planning to run in this UpGrade platform. I should say the UpGrade platform is brand new. We've only been developing it since November. We are just about ready to go live with the first version of it, but we haven't actually run field experiments in it yet. So this is an experiment where we add metacognitive messages. So on the left, you see a screenshot of a Mathia workspace where students are learning to simplify expressions. And we're going to encourage students to ask for hints by giving them messages that explain to them that asking for hints may help you learn more quickly. So this is an example of an experiment that we could probably assign by student within class, but maybe for equity issues, we might decide to keep the class consistent. And we might use an outcome measure, the use of hints. So we may look for students to be more appropriately using hints, and in particular, asking for hints after students make errors, for example. Second type of experiment, this is a more content-focused experiment. We have a lot of virtual manipulatives that students use. So this is a fraction bar representation that students are using to understand fraction division. So it's a fairly complex representation. Students will take multiple steps in dragging and dropping different parts of the fraction bar to complete a fraction division problem. And I should say the context for Mathia use, at least prior to the coronavirus, was students using it in school with their teacher present. Obviously now students are using it remotely with their teacher remote. But in any case, for the class assignment situation, this is one you probably do want to assign by class, because if the teacher is providing additional support and instruction to students, you want to keep a consistent approach for the teacher. And we might look at the amount of time that it takes students to master. So what we're looking at when we design different variants of this fraction bar manipulative is which one gets students to master fraction division more quickly. Another experiment, we've been looking at variants of this for a long time, is there's some research that shows that students, particularly in middle school, are sensitive to the names that are used in problems. So in word problems, they're often kind of character names. They're often chosen from stereotypically kind of white middle class contexts, names like mine, Steve, Bob, those kinds of names. But those names may be less familiar in some communities, and it becomes a kind of connection issue. And so, like as an illustration of this, I pulled this off the Social Security website. Mateo and Santiago are the top two names for Latinx boys, Latino boys, but they're number 37 and 81 overall of names. So the names that are familiar to students from particular communities are different. And so what we want to do is design a system where we can use names that are familiar to that student. And you can imagine doing it in a number of different ways. Maybe in one condition, students can pick names that they like or are comfortable with. In another condition, we might automatically pick names based on registered students from that school, on the assumption that students are familiar and comfortable with names of students at their school, or we have a control group where we have fixed names. And again, we might be looking at time to mastery in an experiment like this. And in terms of assignment, we probably, for equity issues, want to assign this by class, but again, there are other possibilities. Also, one thing when I say class, oftentimes we want to assign even by teacher. So particularly with the fraction experiment, we might want all the classes for a single teacher to have the same experience, so that teacher only needs to think about one of those models. Okay, so those unit of assignment issues, I think, are primary, and one of the reasons why UpGrade is preferable in the educational software context to a number of the other commercial A/B testing platforms. You can do this cluster random assignment, and not only that, it will follow through on all the logic for that. So it'll manage that. So when you're managing consistency for individuals, one of the concerns that you have is if the experiment doesn't run for the whole school year, it's able to do reasoning about what happens to the student who did fraction division before the experiment started. And then if we're, does that student get put into the experiment? Does that student change over to the experimental condition when the experiment starts or not? You can control those kinds of things. But it may not be important for other individual assignment experiments. With classes, when you think about that fraction manipulative kind of experiment, there are some cases where you're going to have to settle. So if a student is assigned to condition A in class A and then transfers classes and now is in condition B in class B, what happens there? Or again, if the student starts fraction division before the experiment starts and you want to do group assignment, does that mean the whole class is excluded for the experiment, or do you assign within the class with the exception of that student? Those kinds of logic and reasoning are all worked out by the UpGrade server. And the architecture looks like this. So one of our principles is we wanted to keep this as an experimental server that is separate from the primary educational software. So for us, this center box is Mathia. It's going to query the UpGrade server to get student conditions. The UpGrade server doesn't store any PII, so there is anonymous IDs that are passed back and forth between the software and the UpGrade server. The UpGrade server also knows about student membership in classes, schools, those kinds of things, again, in that kind of anonymized way. The educational software, of course, will get implemented so that it can implement the experimental conditions. Students will receive those appropriate conditions. And then when it's time to analyze the data, there's a process for linking the anonymized assignments to the student data so that we can look at outcomes. Oh, and importantly for commercial companies, we also have a customer support interface so that if there are phone calls or emails about bugs or concerns about particular students or classes, our customer support department can understand what condition the student is running in, if that's important. As far as the design process, so within Carnegie Learning, we're very focused on looking at experimental interventions that are built on learning science and that are practical in the classroom. And so what we're going to do is conduct these design thinking sessions focused on particular topics, including learning scientists, teachers, students, perhaps, and technologists who can tell us what is technologically possible and feasible in the time that we have. We're looking at things like reducing the amount of off-task time that students have, so increasing their engagement with the software. I talked a little bit about appropriately using hints. We may also do some experiments with our teacher reporting system to try and encourage better use of reports by teachers and better feedback to students on things like progress to mastery. And so to get involved, I will emphasize again, if you are an ed tech developer, you have a software platform that could benefit from running these randomized field trials, please get in touch with us. We'd be very happy to talk about your requirements and how UpGrade might work for you. You may also wish to host an UpGrade server. For researchers, these design sessions, we're in the process of recruiting for these design sessions. If you have a learning science-based principle or idea that you think would be good to test with hundreds of thousands of students, let us know about that. And for teachers and administrators, we're also looking for design team members who can help us play out these designs in ways that are going to really work for students in classes. Okay, and I'm going to leave that screen up, and I guess we can go to questions.
Yes, thanks, Steve. Let me start with a question from our audience, and please engage and start sending us more questions. The question from Chris is whether this is similar, the platform can work, or similar issues are available for higher education, and to your broader perspective of whether similar strategies could work in social sciences and humanities.
Yes, definitely. So there's nothing inherent to UpGrade about a grade level, a particular educational approach, or a subject. So I'm going to go back to the process diagram here. Really, it's a very simple kind of API. So whatever the educational software is doing and whatever environment it's implemented in, really it's just querying for a condition. The UpGrade server manages this kind of random assignment, including all those kind of anomalous conditions. But at runtime, the educational software just basically says, is this student in condition A or in condition B, and does the right thing. And so that'll work fine in social science, non-math domains, in higher education, all that. I would say, our particular advantage over commercial A/B testing platforms is the cluster random assignment, so, which happens in higher ed as well, maybe a consideration. But there's also it works just fine for individual assignment experiments as well.
A quick question from Bob regarding the underlying technology. Is it open source, UpGrade?
Yes, did I not mention that? It's open source.
Okay.
Yes, so yeah, if we are in the process of building a community of developers who can contribute to the project, but there's also the possibility, if you have special needs that are somehow different enough from the main UpGrade branch, and you want to fork it off and do your own thing, that's a possibility as well.
Let me follow on that before I take another question from the audience that has been typed. Can you give us some idea about the timeline once the design team comes together until that is implemented as an available study? What timelines are we looking at, and how much effort that takes?
Yeah, well, obviously
sorry, and if you can sort of elaborate also on Elizabeth's broader question of, what will take for these experimental platforms for researchers to engage, propose experiments, and so forth.
Yeah. So I'll say, like, we have a number of simple experiments designed that I haven't talked about here. Things like, so within our software, we judge when students have mastered a topic and move them on to the next topic. That's the nature of adaptive software. We use a technique called Bayesian knowledge tracing to determine student mastery of each of the underlying knowledge components that students are expected to master. A number of experiments that we've run already prior to this system and will continue to run much more effectively and efficiently after we have this system up and running are experiments that use data to set the various parameters that determine student mastery within that algorithm. Those are kind of experiments, I didn't mention them because they're not the kind of things where you're going to have a design session with teachers and researchers. We understand how that goes. Coding up one of those experiments within the UpGrade system literally takes an hour within our system. Whereas if we were to redesign fraction manipulative, there's the design process, which we expect to take probably about 3 weeks. So there's the design session itself, which is a day with several kind of follow-ups with the designers. To get to a design process typically will take us, like I said, about 3 weeks. The implementation of that, it's very hard to predict because it will depend on how radically different it is from what already exists. If we're like, tweaking up an existing design, again, that could take, a couple of hours. If we're completely redesigning it from the ground up, it could take substantially longer.
Thanks. A question from the audience, Samthai asks, what considerations are made in relation to students with disabilities or English language learners?
Yeah, it's a great question. So we're very focused on, we're also like looking for designs that particularly serve particular populations. So um, within the system right now, we don't anticipate running experiments where we're actually kind of providing a particular solution or feature to students with known demographics. But what we're trying to do is more universal design for learning. So we're trying to design features that work for all students. And then when we get to the data analysis phase, that merging of the anonymized condition data and the actual student data can also merge in demographic data. And so we can look at the impact on those groups of these kind of universal design features. We've been thinking about as a platform ways where we could actually take demographics into account on the random assignment, like do a blocked assignment. So we're ensuring, for example, that a roughly equal number of equal English language learners are in each of the conditions that we're doing and things like that. That's not a feature that we have in there now, but it's something we're thinking about.
Um, Another question that just came from Teresa. So what type of information is provided to teachers and how might teachers use such information in their instruction? So what's the feedback mechanism towards the students?
Right.
And maybe we have a minute and a half. I see Christine probably. She would like to switch us soon.
Yeah, so most of the communication to teachers is through the educational software platform itself, not through UpGrade. But one of the things that we're really interested in doing is providing UI for teachers and administrators to run experiments themselves. So particularly like administrators talk to us a lot about how teachers use reports, and they have like a lot of really good ideas about how they might want to encourage teachers to use data better to guide their instruction. And so what we want to be able to do is give those administrators a platform where they can experiment with it. And part of the idea behind that is that it gives the administrators kind of ownership of the processes that they're giving to teachers and feedback on what's working and what isn't.
Okay, I think we have more time actually. That's what
okay.
indicated. So we'll take more questions. Let me switch. So one question from Tanu, keeping higher education in mind, would your design change based on student demographics like education, age groups, and so forth?
I think, as I said before, like certainly when we design our software, like for middle schoolers versus high schoolers, there are differences other than the content, just design-wise. There are differences in the way we design software for one group or another, and you can target experiments within those platforms or those age groups differently. But generally, we're not taking that into account in the random assignment. But like I said before, it's certainly possible. I'd love to hear kind of ideas for designs of experiments where that's important. And then we can think about how to incorporate that more easily into the platform.
Another question that came from Teresa is about, but right now you mentioned that the data collection is obviously not occurring in person, and what are the challenges that you have experienced when moving to a fully online arrangement?
Yeah, so data collection, you can think about two broad classes of outcome measures that you want to look at. Some are intrinsic to the software. So for example, I talked about like hint use. So we can measure, how often do students ask for hints from the system, as well as kind of patterns of hint use, like do they ask for hints subsequent to making an error, or are they kind of over relying on hints, maybe asking for hints before they even try things. Those are intrinsic measures. An extrinsic measure might be the end of year test score. The advantage of intrinsic measures are they're much easier to collect. They can actually drive the random assignment itself. So you can, in a future version of UpGrade, we want to do what's called like a multi-arm bandit architecture. So we want to be able to, let's say, test A and B and dynamically evaluate which one is working better and start to move students towards the condition that appears to be working better in a way that takes all that into account. But in order to do that, you need to have kind of immediate measures. The long-term measures, though, are often more valid in education. So, we know with things like space versus block practice, with block practice, you might get better immediate performance, but your long-term retention might suffer. And so sometimes you want to have those long-term measures. The long-term measures also, in terms of learning, may be more valid measures of your ultimate goal. Having said all that, and I should say there's kind of an intermediate version of that, which is where you kind of insert external measures into your software. So you may insert pre and post tests into, an instructional system in order to test the results of this kind of field experiment. All of those have various difficulties. Inserting the test there has the potential problem of students taking it seriously. So we've had that quite a bit. These are all like, you can choose among any of these methods when you're designing and evaluating your experiment. And which one you want to do depends on the goals of your experiment, what you want to learn, and also what's feasible for you to do.
So let me build a little bit on that question. For some experiments that have been run over time, for, let's say, as the platform goes on for a number of years, how can you incorporate data from previous years and then, inform the next experimental design? I mean, you mentioned Bandit for an online version, but you also have from the deeper past. Any thoughts on that?
Yeah, so a couple of things. One is, just in talking about running experiments over time, one of the things that's really interesting to me and for researchers out there who maybe are interested in looking at these kinds of issues is I worry that some things that work in the lab in a short implementation don't work over a full school year, right? So, you bring students in, you do some instructional intervention with them for an hour or so. That doesn't mean that if they receive that instructional implementation or approach every day for 8 months, that it would retain its effectiveness. So a lot of the motivational experiments, for example, like motivational messages might be fine, in the short term, but in the long term, particularly in the high school level, students get cynical about them. So they may actually wear off in effectiveness. So experiments that are focused on like doing those kinds of things, educational technology is a great platform for looking at those kinds of issues, particularly with software that is used consistently throughout the whole year. As far as like how those experiments get played out, how they get played out in terms of becoming the standard way of doing things. So, when condition B beats condition A by whatever measure. Well, like I said, one technique is you can dynamically, if you're using intrinsic measures, you can dynamically use those intrinsic measures to bias assignment towards the condition that appears to be working. You don't do that, by flipping a switch. You do it gradually. So you're continually measuring whether, condition B still is working better than condition A. But eventually you get to the point where all of your students are getting most effective condition, if there's a clear winner. So that's one way that the software adapts. The other way is, and particularly when you're using kind of extrinsic measures, end of year test scores, which is what we've often used, you can't adapt to those end of year test scores except on the kind of school year boundaries. And so that's where you would be exporting your data, doing your analysis. And then once you get to and through the UpGrade system, you can manually kind of say like every student gets B, right? And then you've just changed the functioning of your software.
Switching a little bit gears, and I'll integrate two questions from Xianghua and also going back to Bob. Xianghua is interested of learning how to join a design session, and Bob is a bit worried about long-term sustainability of an open source platform.
Okay, so joining the design session, that's easy. Go to the website that we have here, discover.carnegielearning.com/upgrade, or email upgradeplatform@carnegielearning.com, and let us know what you're interested in, and we will try and accommodate you there. We are just setting these up. I'll say, of course, we plan to do kind of face-to-face sessions, and probably we will end up doing some kind of virtual and remote sessions. Sustainability of the open source platform is definitely a concern. So one of the things that we're thinking about is, and I'd love to talk to more EdTech developers about what seems to make sense for them. One model is UpGrade could become like a hosted service. If you're a small EdTech developer, you go to the UpGrade service, you license the ability to use it. It would probably be pretty cheap, and you could get up and going very quickly. So equivalent to what a lot of platforms like Optimizely do. The other way, since it is open source, is you can set up your own UpGrade server. We're going to be setting up our own UpGrade server for Mathia, which we run and administer. We may, certainly in the first phase, we'll host other people's experiments within the UpGrade server, other developers' experiments, but we don't really see that as a long-term business for us. Could be wrong, but for right now, I don't.
Thank you. It's almost 4 p.m. I don't know if we have time for any last-minute question before Christine switches us.
All right. Well, thanks very much, everyone.
Thanks very much, Steve. I don't know, while we're waiting for switching, maybe a couple of quick thoughts on the Elizabeth's questions on the larger issues with infrastructure. I don't know if you want to chime in.
Yeah, I mean, I think one of the things, the design session, so it's easy to talk about the availability of the UpGrade software and platform, but I think actually the bigger impact is those design sessions. So what tends to happen, a lot of times, I talk to people about A/B testing, and I will say I don't know entirely what to call this sometimes. A/B testing often implies like really trivial changes, like I'm going to change the color of this button from red to green and see if people click on it more. I think the real value and impact that we'll get is by experiments that are really kind of based on these learning science principles and that get at deeper understanding of the principles by which, like from a learning engineering perspective, like what are the principles that you use to build educational software? So that's what I'm most excited in doing through this platform. Yeah.
Thank you so much, Steve. I think Christine is ready to.